Hi, this is Math 2231, remote delivery for April 27, 2020. This is part 3 for this day, and it is the average value of a continuous function on a closed interval. And make your learning sharp by using tools like this as we go forward. Now, by way of introduction, if I ask you to calculate the average age of students in a class, what you would do is you would add up all the ages and you would divide by how many students there are, and that would give you the average age. In a statistical sense, that means we would be finding the mean, or x bar, and again what we would do is we would take each age, x sub j, add them up 1 to n, and divide by how many students there are. Now, since the definite integral really is a limit of Riemann sums, we're kind of doing the same thing, and then we just have to figure out, so what happens in terms of dividing by how many students there are? What's the analogy of that? And this is what the theorem tells us at the end of the calculations. The average value of a continuous function over a finite interval AB is given by, and this is a number, the average value of this function. And by the way, you know a continuous function on a closed interval is bounded, achieves its max and min, so you know it is bounded. But anyway, this is a number. This is the average value is 1 over the length of the interval, which is going to be b minus a, because b is bigger than a. And then this is going to be the integral from a to b of f of x dx. This is a number, that's a number, and so this whole thing ends up being a number. Let's apply this in solving a problem. So let's determine the average value of each of the following functions on their given interval. So here is f on this interval, and here is r on this interval. You know what to do and when to do it. Let's see how you did. Okay, so this number is going to be 1 over, this is 5 over 2 minus a minus 1. So that is going to be 7 over 2, but 1 over 7 over 2 is 2 over 7. That's a constant that's out in front. Here you're going to add 1 to the exponent, divide by the new exponent. Pull the minus 5 out, you're going to add 1 to the exponent, divide by the new exponent. Here you're going to have to pull 6 out. You're going to do a u substitution. U is going to be pi t, and you go through the whole thing, and you will get, this is the antiderivative, and we'll substitute these values in, 5 over 2, n minus 1, and we'll subtract the 2. The sign of minus pi is going to be 0, and the sign of 5 pi over 2 is the same thing as the sign of pi over 2, pi over 2, yes. So that is 1. You're multiplying this all the way through. And when you do the calculation, and again, you would be doing this calculation without a calculator on the upcoming assessments, but this is the answer that you would get. And some of my students would say that's the ugliest number they've ever seen in their life, but I would tell them there are no ugly numbers, just like there are no ugly babies. So that is the exact answer. The second problem, finding r average, you're going to compute this. The length of this interval here goes from minus pi to pi. So whenever you do that, that is going to be 2 pi. You might very well use a u substitution. You could let u equal this. You end up having a minus times a minus, and you get another factor of 2 in here, and we substitute those values in. Now it turns out the cosine itself is an even function, so when you put this number in, or minus that number and subtract them, you're going to get 0, and so the answer to this is 0. Now you might be surprised and say, how could the average value of that function possibly be 0 over that interval? Well, it turns out that the positive areas cancel out with the negative areas, and so that is apparent from the graph. Recall that that was the net area, or I actually wouldn't have done this calculation at all because I would have simply observed that the integrand is an odd function. And so if you're integrating an odd function over from minus a to a, where a is any real value, you will get 0 for that with an odd function that will behave like this. So there's a lot of ways to get that answer, so the average is going to be 0. Now, we also have another theorem. So this theorem says, and it's similar to the mean value theorem that we had for derivatives, but now it is called the mean value theorem for integrals. And what it says is, if f of x is a continuous function on AB, then there is a number c in AB such that the integral from a to b of f of x dx is equal to f of c times b minus a. Now, if we rearrange this, divide both sides by b minus a, we get this. So another way to think about this theorem is that the theorem is telling us that there is a number c between a and b such that f of the average is equal to f of c. That says if f of x is a continuous function, then somewhere in AB the function will take on its average value. So let's look at another problem. So here I'm asking you, and this is kind of a standard type mean value question, determine the number c that satisfies the mean value theorem for integrals for this function on the interval 1 to 4. You know what to do and when to do it. Let's see how you did. So here was the function, here was the interval, and so we will calculate the value of this integral. And we say there has to be a c such that f of c, so we're taking c and plugging it in here. We're trying to find the value of c, so we plug c in there for x and we get this, and the length of the interval is 4 minus 1 or 3. So you see we're setting up this. Now we'll find the integral here, and what happens when we do this integral, we'll add 1 to the exponent, divide by the new exponent, pull the 3 through, add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the exponent, put those in, and we'll have this, we'll distribute this, and we'll get 99 over 2 is equal to 3c squared plus 9c plus 6. Now if I move this over to the other side, what I'll end up with is a quadratic equation, and I'll solve that using the quadratic formula. Now you do get 2 roots, but you see the mean value theorem tells you that the answer must be between these 2 numbers. So even though we get 2 roots from the quadratic formula, only one of them, actually they both could be, but in this case only one of them is within that interval, and I did do a calculator thing to figure out which one was what was in there, and I'm not going to let you do a calculator, but you could estimate that. This thing is a little better than 8, and you could figure that out quite readily without the calculator. And so the answer to the problem is this. The exact answer is this, not that. Okay, so now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. See you in